I don't know if this is confusing you guys so far because you can't see me, you can't ask questions, and it's a lot of stuff. Or hopefully, if anything, I kind of get the idea, I just need more practice. So that's what today and tomorrow are all about. So I'm going to practice another one with you here, and we're going to go out through every single thing, from the black to the blue to the green, graph it. You're going to try another one out. And remember, I'm going to give you an answer key to the whole packet so you can always take a look at it. So here we go. Let's just try this out. And start fresh if you're kind of feeling overwhelmed. First guy, want roots. So f of x needs to be 0 for the original guy. When are fractions 0? Do I worry about the top or do I worry about the bottom? Only at the top. So I got 0 equals x squared. We're only worrying about the top, so that's when x equals 0. So I only have one root. Okay, if I was to graph it right now, and we aren't, all I know is it's going to hit the axis just once at 0. Critical points. I'm going blue. We've been doing this all week so far. So I take my first derivative. That's a quotient rule. That's okay. U is x squared. U prime is 2x. V is x squared plus 3. V prime is 2x again. So I'm going to have f prime of x equals 2x times x squared plus 3 minus, you guys are probably right. I'll do it in your order. U prime v minus u v prime all over v squared. Okay. Simplify this a little bit. This is where simplifying does matter. This is where your algebra skills do matter. So I got 2x cubed plus 6x minus 2x cubed all over x squared plus 3 squared. Never worry about the bottom. Keep the bottom as is. Hey, 2x squared cancel. So my first derivative is only 6x over x squared plus 3 squared. Now remember, I need to set this equal to 0 or equal to undefined. Zeros happen only on the top. 6x equals 0, that's at 0. That's a critical point. Undefineds only happen on the bottom, when the bottom is 0. Now if you look at this, x squared plus 3, if I'm trying to see when that equals 0, x squared, anything squared, gets me something. Plus 3 is always positive. This never has a 0, so there's no undefined guys. So the only guy we need to worry about is x equals 0. So from that, luckily this is a smaller box to make. X, y, y prime. I do care about the y's on my first derivative. X equals 0. What's my y? Plug into the top. 0 squared over 0 squared plus 3. Y equals 0. And this is when my slope is 0. I don't care about anything here. Anything here. I just care about the signs now of my first derivative. I would focus on this guy for checking out my signs. Notice anything on the bottom squared is positive, so I only need to really worry about the top part. Anything less than 0 would be a negative over a positive. That's a negative. Anything greater than 0 would be a positive over a positive, which is a positive. So if I wanted to somewhat sketch this, all I can really give you right now for this problem is I go down, I hit a 0, and I go back up. So if I go down, I hit a 0 and go back up. Do you agree this could be what this guy looks like. But what's kind of interesting is this seems to just have turned into a parabola. I have my going down, I have my 0, I have my going back ups. If you graph x squared over x squared plus 3 on your calculator, it's not going to look like that. So we have to come up with what it really looks like. Now realize what I could do. I could do something like this. Now notice, I'm still going down everywhere here to a 0, and I'm still going back up, but do you see how I kind of bent? This is concave up, and then all of a sudden, at a point, it looks like I kind of started to bend back down. So that's why the second derivative test is going to help us. It's going to help us see how things bend. Instead of just saying, oh, I have a parabola, it could bend out a little bit like this red guy I drew. So let's take a look at that second derivative. Now, when I need to do the second derivative, as a heads up, you did everything for the quotient rule, and your quotient rule gave you this, and it gave you this, and you simplified to here, and you finally got to there. That's the piece I'm going to use for the second derivative. So I'm going to go to a new page just so it doesn't get overwhelming. And I'm going to write down that I had it as my first derivative was 6x over x squared plus 3 squared. And now we're going to need to do my second derivative. So I'm now finally on that piece. Again, it's going to be a product, or sorry, a quotient rule. Use 6x, u prime is 6. V is this big dude. V prime, it gets bigger. It's a chain rule. I pull the 2 down, x squared plus 3, a 1 stays up top, times 2x. So let's see what we get. We're going to have to do some algebra to simplify again. U prime times V minus U times V prime. Now 2 times 2x is 4x, x squared plus 3. All over x squared plus 3 to the 4th. Now I know this looks big, but let's see if we can simplify just a little bit for this. I'm going to simplify and we'll go from there. Don't expand out yet. Let's see if we can avoid expanding out for a moment. This second piece here would be minus 24x squared plus 3. Again, all over this huge guy. Now, if I want to factor, I'm going to try and factor some stuff out of this. The 6 and the 24, I have something in common there. So I can take out a 6. And let's see what else I have in common. I have x squared plus 3. I know I have 2 of these. But over here I have x squared plus 3 and I only have 1 of them. So I can take out an x squared plus 3. Let's see what we have left over. If I already took the 6 out, I don't have any more 6s, but I do have one of these guys left, one of the green blobs. If I take a 6 out of 24, that's going to be a minus 4x squared. Hey, that's it, because that green blob already took out. All over x squared plus 3, all raised to the 4th. This is where algebra helps you guys. I'm just telling you it now. Second derivative again. Let's see what I get. Well, I won't cancel anything yet, but I got 6x squared plus 3. And then in here I got x squared minus 4x squared is minus 3x squared plus 3. All that over x squared plus 3 to the 4th. And hopefully you can still see this as I expand down again. Finally, I would just say this. If you notice, I have an x squared plus 3 on top and 4 of them on bottom, so that can cancel at least one of them. And I can say x squared plus 3 to the third, because one of them canceled with another one. With this, I know that was a lot of work for the second derivative, but what's really nice is all you care about with that is the second derivative being 0 or undefined. So let me see if I can copy all this, finishing it on this page. Oh, that went really big. I need to see when this equals 0 or it's undefined. Well, again, we mentioned undefined comes from the bottom. That's never going to be 0, so we're okay with that. We only need to worry about the top. On this top, I got 3x squared plus 3 equals 0. X squared equals 1. X equals plus or minus 1. So if I set up a boxing here, and I have x equals -1 and x equals 1, and all I'm going to get here is my second derivatives. I know this guy is 0. I know this guy is 0. Now let's do some sign checking here. If I plug in 2, let's see what I get here. When I plug in 2, 2 squared is 4 plus 3 is 7 cubed. On the bottom it's positive. And on the top, 2 squared is 4 times the -3 is -12 plus 3 is a negative. That makes that guy overall a negative. The best guy here I would choose is a 0. 0 on the bottom will be 3 to the third, which is positive. 0 on the top remains positive. That guy gets me a positive. And I might try a -2 here. -2 squared plus 3 is going to be positive on bottom. And on top, I'm actually going to get that one to be a negative. So it's that. So my reminder was, all we had come up with so far was I had a root at 0. I had a critical point at 0, which would be 0, 0. Okay. I know everything went down here and went up here, and this part was 0. Now I can add in some more stuff to this. At 1, wherever that value is, kind of 1 comma whatever, remember I don't really care about the y, and over here at -1, comma some y value, I had my inflection points. And everything went concave down, then concave up, then concave down. So look how I draw this, and we'll see if this works. I need concave down. Now stare at that. My slope is negative, but I'm concave down. Then I still need to continue down, but now it needs to be concave up. Now it's flat here. Continuing concave up. And finally, I still need to be positive, but I need to be concave down again, so it's going to look like that. So what I would say to this is this piece here is concave down. This piece here is concave down. But there is one little section here which was concave up. So as a rehashing, this was my critical point, and it happens to be a global minimum. And then these two red points here are my two inflection points where I turned my wheel from a concave down to a concave up. That's why the second derivative is so important, is because you would have first thought on this guy that, oh, I have a root there, I have a critical point there, it goes negative, 0, positive, it must be that. With your second derivative, you were able to discover that, yes, my root was there. Yes, I had a critical point there where my slope was 0. But I found out that at 1 and at -1, I had inflection points. And so with those inflection points, I was able to bend down, and complete it with a bend up. Without the second derivative, you would have never known about how it bent later in life, over there and over there. So I want you to try the next one now, which is actually going to be the third guy. This one's about the product rule instead of the quotient rule. Try this one out. My answer to this one is provided on the next page. For homework, just for today, I want you to see if you can get this problem and if you can get the next problem on the worksheet. That's all I need you to kind of worry about for now. All day tomorrow, all you're going to do for 90 minutes is work on that review packet that I just created, and I'll give that out to you tomorrow. No notes, all there, and the answer key will be on Blackboard. So you will already have that on Blackboard, and you can take a look at it now. The next guy is number 3, which is the product rule. My answer is provided here. You can take a look at it after you try it out. And then finish today with trying to look at the 5th problem. Okay. Notice I put it on bounds of -1 to 64. So this is kind of back to Monday's lecture where I put it on a bound where x is -1 and x is 64. And tomorrow you can work on the review packet. And I'm actually going to have the sub hand you that review packet now just so you can have it walking into class tomorrow. Thanks, guys. I miss you guys. Hopefully it goes well, and we'll start rehashing it all on Monday.